Welcome to After Hours Engineering. This is a brief update of what I'm up to and been researching. While on vacation, I was brainstorming on what the next project might be, and I pretty much knew what it was. And I showed it in a previous episode, or at least one of them. And it's based off of two FPGA SBCs from Machdyne Corporation. The previous one I showed was the Ice board. That's this little thing right here. On the front of it and on the back of it is two flash devices. And the other one that I haven't shown is the Schoko from Machdyne. And this is a 45, an ECP5 45F variant. And the Tiger that I used to program it via the JTAG port. And it also has a few, an M-mod and some flash on the other side of it as well. So that's this board right here. We'll do a real quick recap of the Ice board. We have our FPGA. This is an Ice 40. It has 8K LUTs on it, same as the BlackiceEdge MX, but in a BGA form factor. We have SRAM in the form of 8-bit bus. We have the Octal SPI RAM in an 8-bit bus. We have the Pico for programming this via the USB, an SD card, USB, boot switch, HDMI here, and a PMod. We've seen this before, and on the back side is the flash for flash in the bitstream and the flash for the Pico firmware as well. The other board is the Schoko board, and it's an FPGA, but it's an ECP5 45F. So it's much larger and much more capable. It directly interfaces to SRAM, comes with two PMods, an SD card, Type-C, HDMI, DVI, and a VGA port that we'll try to use as well, and a Type A, and then an RGB LED here. The way you program the Schoko is slightly different than what you do with the Ice board. The Ice board, you would come in using a custom program that talks to the firmware on the Pico that then programs the FPGA or the flash on the back. The Schoko board is a little bit different. It still has the flash on the back, but we can program it either in DFU mode via the flash's boot stuff, or we can program it via JTAG. For boot, you cycle the power and the LED will blink 5 seconds the color blue, and in that time you have the option of uploading a new bitstream. Otherwise, it then times out and starts loading in the last program flash bitstream. The other way you can do this, which I recommend, is via the JTAG interface here, and that will allow you to upload straight into the FPGA very, very fast at 6 megahertz. It'll program the FPGA almost instantly. And for me, I'm using the Tiger board in combination with the Open FPGA loader. So these are the two boards that we're going to use, and my plans for them are to learn about SoCs, systems on a chip, and what we can do with them. I've been studying Bruno Levy's Femto RV RISC-V chip, and it looks very promising. It's easy to go through, and I'm looking at porting it over to these two boards and custom tailoring it to target them. So you might be asking, well, what's next? In order to start talking to either one of these boards, I would like to put together a UART system, and I'm in the process of doing that. And I want to set it up so that we use a very simple, basic, memory-mapped modular bus. And by modular, I mean all the devices that will connect to this will all follow this same structure, at least as close as they can, where you always have a clock, you may or may not have interrupts, you'll have a reset, a read and a write signal, an address, and then data in and data out. So this is the UART that I'm coming up with, and I'm in the process of building it and testing it out. And we have a control register here that's n number of bits wide, and in order for the client over here on this side to talk to the system over here on this side, you follow a software-defined protocol using clear to send, request to send bits. These buffers here you can fill up. If you want to transmit something to the client, you write to the address and it auto increments this address. So all you have to do is write to single address repeatedly, and it fills the buffer up with each byte that you're going to send. And then you set one of the control bits to trigger the transmission of these things. The Other way is if the client wants to send data in, it comes in here. It talks to the device first or via the UART and asks, hey, are you ready? Not, go ahead or hold off. And I'll write that in a Go program so that we can talk to the FPGA. Now once that's all done, we'll move on to different devices and try to fit them into the SoC and talk about where we can go from there in the memory map world. Now the map itself starts out at 0, and RAM, the block RAM, is in my design will probably be at the bottom, and then new devices will just come in for, like the pseudo RAM or the quad SPI or octo SPI RAM. The UART will sit somewhere in here, and it has 2 control registers, a data in and a data out, so that's 4 memory addresses, and then whatever devices come out after that. Well, I'm not sure if any of this is going to work, but I'll take it as far as I can, and I hope you find this as interesting as I do. I've always wanted to build a system from scratch, and here's an opportunity to do it. So until next time, peace.